All right, but what if you're given just a table like these guys? All right, so we have laps and seconds. So this is time or seconds per lap. That's our change in y over change in x. This one is our change in x. This one is our change in y. Okay, tables, same as if we're doing it vertically or horizontally. We still say doop doop, 1 to 2 is plus 1. Doop doop, 2 to 3, plus 1. Doop doop, plus 1. Okay, go to the bottom. 90 to 200, okay, that's 110. 200 to 325 is 125. This isn't looking good. 325 to 480 is 155. Now, when I go through and look at this, I don't even need to know about 0, 0, because I can already tell that when I put these two together, that is 1 over 110, which does not equal 1 over 125, which does not equal 1 over 155. So this is not proportional. And we can say no constant rate of change. So we didn't even have to look to see if it didn't go through 0, 0. We already knew because it didn't have a constant rate of change. There was no slope. This isn't a straight line, that means. Okay, in the bottom left-hand corner, right now, write credit card. Credit card. 'Tis the season. Okay, next one. Ah, fractions, you're going to die. No, you're not going to die. You're going to be just fine. Okay, so this is, perhaps maybe doesn't make all the way sense, but this is flour per sugar. And if you've ever made a recipe from scratch, you know that the proportions have to be correct between flour and sugar or things don't turn out right. So first thing we're going to look at here is we're going to say we've got right here plus 1, right here plus 1, right here plus 1. We're going to go up to the top and we're going to do, this is plus 1/2. Oh, plus 1/2. And this is plus 1/2. Well, since everything is the same, we know that we're going to have a constant rate of change. Oops, that's pink. So change in y over change in x. This gets a little bit ugly, but don't freak out. I'll show you an easy way. Okay, so change in y is 1. Change in x is 1/2. Now, fraction within a fraction is a super bad thing. But we know, because we know our rules about fractions, when we say 1 divided by 1/2, when you're dividing fractions, you can also say copy dot flip. So 1 times 2 is 2. So our slope is m equals 2. All right. Now the second thing is we have to know, does it go through 0, 0? Okay. Well, if we continue this pattern, what plus 1 gives me 1? This one would be a 0. And then if we continue this pattern backwards 1, what plus 1/2 would give me 1/2? Again, now we know we've got our 0. Okay. I'm going to show you 2 more ways. Don't cry. This goes through 0, 0. Okay. So we've met our 2 criteria. Goes through 0, 0. We just showed that. And has a constant rate of change. which is our slope. So we know that we can write the equation y equals mx, because all we've got to do is plug in our 2. Now, I'm going to show you 2 other ways that you can find slope. Okay, here's one. There's a coordinate, no fractions. There's a coordinate, no fractions. So I take these 2 coordinates, and I have 1, 2, and 2, 4, and I'm going to find the slope. Pretend I didn't have the slope already. Step 1, label the points. Oops. Okay, step 2, write the formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Parentheses minus parentheses. Okay, y sub 2 is my 4. Y sub 1 is 2. And then, oops, new color. X sub 2 is 2. X sub 1 is 1. 4 minus 2, 2. 2 minus 1, 1. Okay, that's another way to find slope. Now, because some of you don't like fractions, I'm going to show you the really cool way to find slope. Okay, how far is it from 1 to 2? Plus 1. Now, same ones that I started with, I used 1, so I got to start down here at 2. And I used this 2, so I got to start down here with 4. These are why dupe-dupes come in handy. How far is it from 2 to 4? Plus 2. So this is my change in y. This is my change in x. And now I have change in y over change in x. So there's like 12 different ways to find slope on this. Okay, not 12. 1, 2, 3, 4. 4 different ways that I showed you to find slope using 1. And then one way of showing you how to find your 0 of going backwards from your first one. Now, sometimes I'll tell you, you might have to go backwards a couple of times to find if you're at a 0. And if one goes to 0 and one doesn't, then it's not proportional. Okay, good job, guys.